Hello, my name is Ritika, and I'm here to present my science fair project, The Effects of Soil on Water's Refraction. Water contamination is a relevant issue in today's society. Some places have mere concerns about water contamination, while others have serious issues. Finding an inexpensive and efficient way to test water's contamination is still a relevant challenge in today's society. My science fair project tested to see if refraction can be used as a method to test how contaminated water is. Refraction is the bending of a wave as it passes from one medium to another. The reason why refraction occurs is related to the speed of the wave in the medium. The different densities of the mediums result in the wave traveling at different speeds in these mediums. As a wave transmits from one medium to another, its speed will change. The result of this is refraction. As the speed of this wave changes, its angle will also change, or rather the angle at which this wave strikes the surface. This angle is known as the angle of incidence. The result of this angle of incidence is ultimately refraction. Based on this research, one can state that when one mixes a solute in a solvent, the resulting solution will have a different density than that of the solvent or the substance present in larger quantities. Furthering this, one can state that the indices of refraction of the solvent and the solution are different. Hence, when one submerges an object in the solvent versus in the solution, the object will appear differently due to the differences in the indices of refraction. Applying this to a given experiment, when one has a given amount of pure water as opposed to a given amount of contaminated water, objects partially submerged in these two different substances will appear differently because of the differences in the indices of refraction. I form this into a hypothesis by stating, if a given amount of water is contaminated, then objects submerged in this water will appear differently because of the difference in the index of refraction. To test this hypothesis, the following experiment was performed. I built a lowering mechanism as shown on the screen. I then cleaned a fish tank and filled it with 8 liters of water. I cleaned a copper pipe and attached it to the lowering mechanism. I lowered the copper pipe into the water, as shown here on the right. These are setups of how the experiment would have looked. Using a scope, I took measurements from the sides of the fish tank of the copper pipe. The scope's purpose was to ensure that my eyesight was in line with the object, and therefore when I took measurements using a ruler, I was getting the measurements from the same angle. I raised the copper pipe and added half a liter of dirt to this solution. I mixed it in and allowed it to settle before re-lowering the copper pipe into the experiment. I repeated this experiment, taking measurements from the same side using the scope. After getting 1.5 liters of dirt in the experiment, I removed the water and cleaned up the experiment setup and repeated it twice more to confirm my results. On this slide, one can see the different moments in the experiment as I took photos of them. Over here, this is how the setup would have looked in reality, and one can see the different stages and different takes of the experiment as shown on the screen. As mentioned in the procedure, the measurements of the copper pipe while the experiment was in progress would be taken. On the left, the control group, or the measurements of the copper pipe when there's no dirt present in the system, was taken. On the right, the measurements of the copper pipe during the experiment was taken. As one can see, the different sides and the different amounts of dirt are shown. This is the average of each of the 3 experiment runs. On this slide, the analysis of the data was performed. On the right, one can see a bar graph. The bar graph represents the function of the sides as a result of the amount of dirt present in the system. Each cluster of bars is a representative of the side it was taken from. One can see that there's an upward trend in each cluster of bars. This means that as more dirt was present in the system, the object appeared larger. On the right side, a line graph is shown. The line graph represents the side as a function of the amount of dirt present also. Each line is a representative of the side it was taken from. One can see that there's a positive slope on each line. In fact, for the front side, the average slope of this line is 1.08 centimeters per half liter of dirt. This shows that the object appears larger as the experiment was progressing. In other words, the more dirt present in the system, the larger the object appeared. Based on the results that was collected and analyzed, the more contaminated water is, the larger an object submerged in it will appear. This means that one can test how contaminated water is based off of how large an object appears in it in comparison to how large an object appears in pure water. Moreover, this experiment result can be applied outside of just water and contamination. One can test how pure a solution is based off of its refraction index, or how large an object appears in its solution in comparison to how large the object appears in the pure solvent. While the experiment was in line with the hypothesis, there are many potential errors that might have affected the results of the experiment. For example, the lighting of the area that the experiment was performed in might have impacted the data. Moreover, the glass in the fish tank might have also had an impact on the data, as light refracts differently through glass than it does through air. Another potential issue was that the dirt added to the system was measured in liters. If it had been measured in grams, the results would have been a little more accurate. While there were some errors, this experiment does lead to some further questions in the topic. For example, how do different colors of light refract through different solutions? Moreover, how do the different components of soil or the different minerals dissolve in water and impact the refraction index of the resulting solution? Thank you for listening, and stay healthy.